Okay. So let's make sure it's zoomed in, ready to go. Now, parent functions. All right, pretty simple. We're coming at it with the constant function is going to be f of x equals x to the 0 power, right? So that gives us a line, horizontal line at wherever, 1, -1, okay? And then we have our linear function, okay? So that's f of x is equal to 1 to the, or x to the first power, okay? Quadratic, x to the second power. Or now we're starting to get nonlinear, okay? And we have that u, and then we take that u and we twist it, right? And so we're going to take all those y values, right? All these y values here, and we're going to twist them, okay? And make them negative. That's the cubic. So instead of squaring them becoming positive, we cube them, they become negative, okay? Then we're getting into the quartic, quintic, the fun ones, right? So quartic is f of x, x to the fourth power. That gives us 3 max and mins, right? And a possible of 3 max and mins. So it could look like a W, right? Now, obviously, if it's negative, this could go like this. If this is negative, it's going to go like that. If this is negative, everything flips at the x-axis, right? So the quintic value, f of x equals x to the 5th power, right? That's as high as we go. And then we don't really worry about memorizing the rest of them, okay? And we just have to remember, if it's a power of 5, we have possible 4 maximums, 4 humps, okay? So we're always smiling at the end, right? Always have a face at the end. And we have a possible 1, 2, 3, 4, okay? And then the fun ones, exponential function, right? And we're going to use this for exponential decay and all that stuff. So when b is greater than 1, okay? So it's always b to the x. Your variable becomes an exponent. That's why it's exponential function, okay? Now, when it's greater than 1, right, we can twist this thing around, and that's why the shaded value becomes this green area. So when it's between 0 and 1, it gets flipped on the y-axis, okay, because it becomes negative, or not a negative exponent, sorry about that. The b becomes a fraction, and so as it gets bigger and bigger and bigger, it gets closer and closer and closer to 0, and as it gets smaller and smaller and smaller, it gets closer and closer and closer to infinity. So that's why it flips, okay? So this shade becomes blue, big for between 1 and 0, and this one is, the blue shade is small between 1 and 0, okay? So what I usually just tell my students, just graph a basic one, either this one, or you could graph these two. You don't have to do the shaded blocks, okay? Then logarithmic function, okay? So the function equals the log of x, okay? And you'll see that this goes off to infinity this way, and then as it gets less than 1, it goes down to negative infinity, okay? Rational function, okay? Well, what that is 1 over x, okay? So anytime you have x in the bottom of the fraction, all right? And that's when you're going to have these, where you have this asymptote, right, at 0, and you're going to infinity as you get really close to 0 on this side, but as soon as you cross 0, you're coming back up from negative infinity, right? And then coming up and getting really close to this 0, going towards infinity. So, real cool. 1 is your value there, is where it crosses. A negative 1 on this side is where it crosses and heads over to that 0 asymptotes. So you really have 2 asymptotes here. Boom and boom. And later on, we'll show you that those rules for asymptotes are over here, and why that happens. But right now, we just want to know the parent function and what's going on. Absolute value of function, a parent function, is basically f of x equals to the absolute value of x. This looks like a quadratic, but it's not. It's a v, right? Because basically it's this line, but everything that gets negative becomes positive, and that's why it becomes a v. Okay? Square root function. So, fractional exponents. We're going to get in big on these, okay? So, get ready to dive deep into these functions. And but the parent function to the square root function is, remember, square root really has a hidden 2 right here. That root, just like the root of a plant, is in the bottom of the fraction. So that's why it's 1/2. Okay? So 1/2 or square root x. Okay? Whereas the cube root, right? So, oh, and by the way, the graph, it goes up and it starts at 0 because you can't take a square root of a negative. It goes up to infinity, right? Hopefully this is still recording. Yes, it is. Okay. The cube root function, right? Okay. Now this gets a little tighter, goes off a little faster, right? But the negatives you can do. You can take the cube root of a negative, right? And so that's why we do have values less than 0 here. So cube root, again, the root is in the bottom of the fraction, so it's 1/3, right? Or the radical with the 3 in it. The 3 is not in front of it, it's in the radical, okay? Not inside the radical, in the little v part to the beginning of that radical, okay? So, parent functions, there we go, all right? Oh, I was supposed to wear my, I'll wear my Western wear on the next one. We're going to talk about power rule next. Right?